In our last couple of examples, we will be finding the volume of solids with known cross sections. We have two formulas here. Which one we use will depend on whether we are taking cross sections perpendicular to the x-axis or perpendicular to the y-axis. Let's begin with example 7. So they tell us that we have the volume of a solid where the base is inside the circle. X squared plus y squared is equal to 9. I'm going to do a very small sketch of that over here. That's just a circle centered at the origin with a radius of 3. We're going to do a more detailed sketch in a bit. And we're going to be taking cross sections perpendicular to the y-axis, and those cross sections are going to be squares. So first, to help us wrap our head around this problem, we're going to redo our drawing. I'm first going to redraw this, and I'm redrawing this in a way so that it looks like we're looking at this from a different angle. I'm not drawing it in traditionally how we usually do, that small sketch I did over there. Typically when we sketch things, we sketch them in 2-dimension, and we sketch them as if they were flat on our paper. But here we're talking about a solid, so I'm going to try to orient this to look like it's in 3 dimensions so we can see those square slices that we're taking. So this is still the same circle. Here's my y-axis, here's my x-axis. Now let's start talking about what these squares look like. I'm going to start at the back. If I take a cross section that's a square, there's one side of the square. Let's say that's the bottom of the square. Here are 2 sides of it, and there is the top of that square. Now, what if I took a slice over here? Well, there's the base of the square again. It's inside the circle. Notice that that side is longer than the first side. I'll go up and finish forming that square. So already you can see I'm starting to form a solid here, where starting from the back, I had a smaller side of the square, and as I move forward, the side of my square is getting larger. And that continues to happen as I continue to build out this 3D shape that we are kind of staring at as we slice. So to help us kind of conceptualize that, this is what we're working with here. There's the circle. We have been drawing in these squares. Notice that depending on where you slice, right, if I slice in the middle of the circle along the diameter, I get the largest square. And when we put all those squares together, we kind of form a solid like this. Area of a cross section. If we know the area of one of these slices, if I can find the area of one of these squares, I'll just integrate over all of those areas to give me the volume. So let's talk about what the area of an arbitrary square is. Well, the area of a square is simply side squared. I'll just write that as s squared. But the idea is that we want to add up the area of all of these squares. But if you notice, the sides of these squares, if I draw them in the plane with the circle, all have different lengths. So I can't simply represent it as s. They're all going to be different. So we need a generic representation of one of these sides. I'm going to write it as s of y. And the reason I'm writing it with respect to y is because we are taking our cross sections perpendicular to the y-axis. When we're perpendicular to the y-axis, we want to write the area in terms of y and integrate with respect to y. So first, thinking about the fact that we're integrating with respect to y, thinking about this picture here, I want the y limits on this circle, which run from -3 to +3, and we need to represent one of the sides of this circle, and we need to represent it in general. So if I think about this red length right here, I would be able to represent it if I knew what this horizontal distance is right here, because it's just double that horizontal distance right there. Well, that horizontal distance right there is just simply some x value. And so the length of that red side is simply 2 times x. If this horizontal distance here is x and this horizontal distance here is also x. Now remember, that x lands on the circle, and the equation of the circle is x squared plus y squared is equal to 9. That implies that x is equal to 9 minus y squared. X squared is equal to 9 minus y squared, which tells us that x is equal to the square root of 9 minus y squared, that distance. So if I want to write the side in terms of y, It's 2 multiplied by the square root of 9 minus y squared. So the area of the square we will find by squaring one of these sides. We need to square the 2, and we also need to square the square root. Squaring the square root cancels it out. So now we have an expression for the area. We have an expression for a of y. So now we need to integrate it from our lower y limit of -3 to our upper y limit of 3. And we're integrating with respect to y. The integral of 36 is 36y, and the integral of 4y squared is 4y cubed over 3. And we will evaluate this from -3 to 3. Final answer of 144 for the volume of this solid.